Welcome to springlib.
Okay, we have several carbocations here. And they're all on dimethyl cyclohexane. I'm going to clone this a few times. It's the same molecule each time, just a different placement of the carbocation, right? We've got a carbocation here. And I suppose I may as well clone this carbocation as well. Okay, carbocation here, carbocation here, carbocation here, and carbocation here. So what do we need to do for a carbocation to rearrange? Okay, we're going to need our carbocation to be primary or secondary, right? Because the goal is for either primary to become secondary or tertiary, or for secondary to become tertiary, right? Carbocation rearrangement will only help it happen if it would increase the substitution of the carbon with the positive charge. The other thing we need to do is neighbor. We need to neighbor a hydrogen or a methyl, right? There has to be something that can swap places with the carbocation. Okay, so now we know what we're looking for. Okay, here's a secondary carbocation. Yep, that's on our list. This is possible to rearrange. I guess we'll point one other thing out. If we want, okay, so if it's a hydride shift, then we need to neighbor hydrogen on a secondary carbon, or hydrogen on a tertiary carbon. And for a methyl shift, we need to have a methyl that neighbors, and it needs to be on a tertiary center, or in the case of a secondary carbocation, we need to have a methyl on a quaternary carbon. Okay, that's the only way we're going to increase the substitution. So we'll look again at this. We've got a secondary carbocation, but our neighbors are secondary. This is secondary, and this is secondary. Right? And as we said, if we have a secondary carbocation, what we need to increase the substitution would be either a hydrogen on a tertiary or a methyl on a quaternary, and we don't have either of those. So this is just not going to rearrange. There's no benefit to be gained. If we did a hydride shift, all that would happen is we'd end up with a secondary carbocation here, which is exactly what we started with, right? That's why we need a tertiary neighbor with a hydrogen. Okay, what about here? So now we've got a secondary carbocation. So what are we looking for? Hydrogen on a tertiary. We don't have a neighboring tertiary, or a methyl on a quaternary. Hey, this is a methyl on a quaternary. Can this migrate? Let's take a look at what the product would be. Right? Remember, the methyl and the carbocation will basically just swap places. So our carbocation will be here and our methyl will be here. And lo and behold, that would be a tertiary carbocation, right? 3 carbons attached. So this would be a useful carbocation rearrangement. Okay, so it's probably number 2. Let's look at number 3. Here, once again, our neighbors are secondary. Like, we have a secondary carbocation and our neighbors are secondary. We need hydrogen on a tertiary or methyl on a quaternary, and we don't have either of those. Okay. Okay, what about here? We've got a primary carbocation, and do we have a neighboring tertiary with a hydrogen? No. Do we have a neighboring methyl on a quaternary? Yes. this can move over there. Look something like this, right? The methyl and the carbocation change places. And all of a sudden, yep, now we've got a tertiary carbocation. Okay, so now, which is more likely? 2 or 4. Either of them are possible. They're valid rearrangements that are likely to happen. Which one is more likely to happen? I would say that 4 is more likely to happen. And that's because we go from primary, which is very unstable, to tertiary, which is very stable. Whereas in the case of 2, we go from secondary, which is, yes, unstable, but not as unstable as primary. So let's just call this unstable. We go from unstable to stable. The difference between very unstable and stable is bigger than the difference between unstable and stable, right? Which means that this one is even more likely to happen and will happen essentially quicker because the energy benefits are bigger. Oh, and then one of the possible answers is 2 and 4. So there we go. We didn't even have to decide between the two. So that's answer E.